Hi everyone, my name is Christian Wing, and I'm doing video presentation number, I think, 4? Yes, 4, and that is section 1.7, number 19 from the homework. Alright, so basically, number 19 says, consider an alligator population P of t satisfying the extinction explosion equation as in problem 18. If the initial population is 100 alligators, and there are 10 births per month and 9 deaths per month occurring at time t equals 0. How many months does it take for P of t to reach 10 times the threshold population m? And so beforehand, I have written down all the information from 18, including some notation and whatnot. And so basically, to start out, we need to kind of figure out our goal. We are given a formula for m, but what is m? So again, m is d naught p naught over b naught. And so in this case, d naught is 9, p naught is 100, b naught is 10. So we compute that, and we have 90. So this is our threshold population, and what we need to know is 10 times that, and so we need to know at what time is it 10 times the threshold population, which is 900. So this is our goal, but to get to that, we need to obviously use differential equations and integrate. And so to start out with, we can set up our differential equation. And for simplicity's sake, we won't solve for a or b yet. And so we need to find p of t. All right, so to start out with, we will factor out an AP. So this gives us dp dt equals AP. This is b over a here. And so let's let m equal b over a. And so now we have a minus m in here. For now, we're going to try to separate this. Separate. And so if we do that, we will have, we'll go, I don't know if you can see that or not. Get all the p's on this side. And over here we have ADT, always there, little joke. Now we can integrate. And so on this side, it's pretty easy. This is just AT plus a constant C. But over here, it's a bit more difficult. We have 1 over P times P minus M dP. So, in order to integrate this, we're going to have to use partial fractions. And so to do that, here we have this form. We can break it up. All right, So now we need to try to get a common denominator. And so to do that, we need to multiply. We will have a times p minus m over p times p minus m plus b times p over the same denominator. And since these all have the same denominator, we can say that the tops are equal to each other. So this gives us p equals 1. All right, now that we're at this, we can say, try to solve for a. If p equals m, then 1 equals mb, in which case solve for b equals 1 over m. All right, now that we know b, if p were to equal 0, then a times negative m equals 1. And in this case, solve for a. It was the negative of b. All right, cool. Now we have a and b. So now we can plug those into our integral from above. All right, cool. Now we can pull out from here 1 over m. So now we're left with 1 over p. And we'll go, yeah, we'll keep doing that. 1 over p times m and p. All right, so now we can break these up. And we'll probably switch these around. Oops, can't forget your dp. Remember, this is all equal to the other side of the equation, so it's constant c. And over here we got pretty simple integrals here. Whatever's inside the denominator, put inside the ln. Okay, now we have a pretty decent equation here. And we'll simplify this a bit more. All right, that looks good. So now that we're there, we'll rewrite that. Where were we? Go to e-base both sides here. Let's see. What was I doing after this? Oh yeah, that's right. So we'll go. We can do this because e to the c is basically just arbitrary constant. And so now that we have that, we can pull this out, pull the 1 out. And now we just solve for that pretty easy. A little manipulation here. Eventually we getting too worried about showing every single step. I'm sure you guys can figure out algebra pretty good. All right, so there's our p function, but we don't know what c is, so we got to figure that out. And so we do have some conditions that can make this easier. So the population at t equals 0 is 100. If we plug in m from before, we know that's 90. Oh yeah, that's right. I suppose that's a, isn't it? We haven't actually calculated a yet, have we? I should probably do that first. A, as we saw before, here we go, draw a line to here. A is, what is this? P naught over P naught squared, which this is which equals 1 over 1,000. So that's where that came from. So this is 1,000 times t. But we know t is 0, so this is just leave that 0. And so basically we're left with 100 equals 90 minus c. And then we're left with c being c is 1 over 10. All right, so now we have our full PT equation. There it is. But now we need to know when does our population reach 10 times the threshold of population, which was 900. So, next page. So here's our target. And so that's kind of what we're looking for here. Well, we do some algebra here. This size by 900. Haven't written this down yet, so I guess we'll figure out together. Oh, what is this? 1/10. Let's see. 1 minus 1/10. 1/10 e. I'll simplify that a little bit. We'll divide this. 1/10. All right. Natural logarithm. And that goes away. We have ln 1 minus 1/10 over 1/10 equals 9 over 100 times t. And we have 100 over 9 ln. That's our time. One minus 1/10. Oops, 1/10. Put the syntax error there. Oops. Divided by 1/10. And we have t equals 24.4 months until alligator population